Hello everyone, so this time we'll have the first example for vectors. Say you have the vector A to be equal to 1, negative 2, negative 1, and vector B to be equal to negative 1, 1, 2. You're asked to find the cosine of the angle between B and 3A minus 2B. So let's take a look at the first example. So the cosine of the angle between B and 3A minus 2B can be solved as follows. Since we have, take my pen first here, since we have B equals, vector B equals 1, 1, negative 2, and when we try to solve for 3A minus 2B, this should give us 3. Our A is 1, negative 2, 1, then minus 2. Our B is 1, 1, negative 2. Then 3A minus 2B should give us 3, negative 6, 3. And we have minus 2, 2. We have negative 4. And if we try to simplify this is 3 minus 2. That should give us the following vector. 1, negative 6 minus of minus 2. So that will give us minus 8. 3 minus of minus 4 becomes plus there, so we have 7. Meaning to say, if you recall the formula for cosine, theta, that's equal to A dot B over the magnitude of A times the magnitude of B. But in this case, because you're asked to find the cosine of the angle between B and 3A minus 2B, then we should have cosine theta equals our B here, which is the vector B that you have 3A minus 2B, vector 2B, all over the magnitude of B minus the magnitude of 3A minus 2B. Now, we also have, because we need the magnitude of B. We can also solve here the magnitude of B. What's the magnitude of B? The magnitude of B from our formula is actually equal to the square root of, if B is 1, 1, negative 2, the magnitude is 1 squared plus 1 squared plus negative 2 squared. And that's equal to the square root of 1 plus 1 plus 4, or that's equal to the square root of 6. On the other hand, the magnitude now of 3A minus 2B is equal to the square root of, let's make use of this, 1 squared plus negative 8 squared plus 7 squared. And this should give us the square root of 1 plus 64 plus 49, which is equal to, this time that's the square root of, this is 49, and then 1, that should give us 50 plus 64, so that should give us 50 plus 64. That is equal to the square root this time of 114. Square root of 114. So that from here, we can now compute for cosine theta. That should give us cosine theta equals b dot 3a minus 2b. That should be, our b is 1, 1, negative 2. That we have 3a minus 2b. That should give us 1, negative 8, 7, all over the magnitude of b, which is square root of 6, or the magnitude 3a minus 2b, square root of 114. So that's one. The dot product of this is a scalar, which is 1 times 1 plus 1 times negative 8 plus negative 2 times 7. So that's all over square root of 6. That's supposed to be square root of 6. Eraser. From erase. Should be square root of 6. Okay. Presentation of black. Ayan. Okay. Yan, eraser. That should be, so let's go back to the pen. Should be square root of 6 times square root of 114. But 1 plus negative 8 times, so that should give us 1 minus 8 minus 14 all over 2. I can compute for this. Should give us 2 square root of 19, and that is negative 8 minus 14 should give us negative, this time 7 all over 2 square root of 19. So that's the cosine theta of the angle between B3A and minus 2. Let's take a look at the second problem. So we may end this one here.